Okay, hello students. Today we will learn RK4 method. Okay, so let's learn it together. Right. So what is the motivation behind RK4 method? We use RK4 method, Runge Kutta method, to solve the differential equations. Here you can see a simple ordinary differential equation, and you can see here that the initial condition, this is called initial condition, it is given to you y of 0 is equal to 1. Okay, now the question is solve it using separation of variables. You can see we can separate the variables and do the integration and obtain the analytic answer. Then Euler's method, which is a preliminary or initial method for for solving the differential equations, ordinary differential equations, and then RK4 method. RK4 method is defined as yi plus 1 is equal to yi plus h by 6 k1 plus 2k2 plus 2k3 plus k4. What is the meaning of these yi's? Actually, what we do, students, instead of finding a continuous answer for y, we will go for the discrete answer. Okay, so when we do numerics, we say discrete answers. What is happening here? You have divided the x domain into small batches. For example, you are going from xi to xi plus h, and remember this will be equally divided. Therefore, it will be understood that if the starting point is given to you and the ending point is given to you and the step size is given to you, all the x values will be given to you. For example, if x naught is 0 and the step size is 0 0.5, then of course you can find x2, x3, x4, y naught. Yes, you can find x naught plus h is equal to x1, x5 plus h is equal to x6. So you can always find x is given. The problem is with y, because when you solve this differential equation, the dependent variable is y, and we want to find the value for y. And if it is an analytic method, you will get a continuous answer. If it is a numerical method, you will get a discrete answer, and the index means that y naught will be given to you when you substitute I is equal to 0 here. Y1 is equal to y naught plus h by 6, k1, 2k2, 2k3 plus k4. So actually what are you doing? You are going from y naught to y1. Then you will, to do this, to achieve that task, we will need k1, k2, k3, k4. Once you are done with y1, you will use y1 and x1 to go to y2. Once you are done with y2 and so on, the process will continue till someone has asked you to stop. For example, in the exam, the examiner can ask you to stop at x is equal to 2. That means that you will find y at x naught. Of course, it is given y at x1, which is 0 0.5 y1, then y at x2 which is 1, then x3 which is 1.5, and then x4 which is 2. At these all x points you will find the values for y. Otherwise the examiner can ask you to perform 4 iterations or 5 iterations, or he can straight away ask you to find y of 2 is equal to question mark, y of 4 is equal to question mark, and he will give you the step size. Okay, is that understood? Now let us understand the problem, the method with the help of a problem or a differential equation. You have this differential equation, dy by dx is equal to x cube minus 1.5 y. The problem is that now we want to find the solution, and first we need to be clear about f of xy. Students always simplify the given differential equation and write it in this form. That is, keep the derivative on the left hand side and the remaining terms on the right hand side. Now f of xy is x cube minus 1.5 y, and now k1 is f of xi yi, k2 is f of xi plus h by 2 yi plus k1 h by 2. Now what is happening here? For the better accuracy, RK4 method will not go straight the way from xi to xi plus h. It will stop in the middle, xi plus h by 2, and will work for functional value at xi plus h by 2 yi plus k1 h by 2. This will help us to improve the numerical result for anticipated for xi plus h. All right, so this is the plan. Now look at this formula. K1 is at this point, K2 and K3 are at this point, K4 is at this point. Okay, now we will average these values. We can see 1, 2, 2, 1, the coefficient, total coefficient 6, and we can see the denominator here 6, and we can substitute these values. So let us go through the first iteration. For the first iteration, simply substitute in all the formula I is equal to 0. You will get y1 is equal to y0 plus h by 6, k1, k2 epsilon, and k1 is equal to f of x0, y0. Now the question is, what is x0, what is y0? Remember, for a differential equation, the initial condition is given to you. X0 is this 0, y0 is this 1. Okay, for example, if I change the initial condition, kindly read the question carefully and follow the given initial condition for x0 and y0. Next, we will go for the x naught, y naught. In this question, x naught is 0, y naught is 1. Now look at f of xy. This is f of xy. So 0 cube minus 1.5 times 1. You will get minus 1.5. Now the next step is to change the inputs. How will you change the input? You will say x naught is 0 and 0 plus h by 2. H is given to you in this question. I have given h is equal to 0.5. If h is 0.1, then of course h by 2 is 0.05. For this question, h is 0.5, so h by 2 is 0.25. So x naught plus h by 2 means 0 plus 0.25, which is 0.25. Y naught plus h by 2 times k1. K1 is, now you have worked for k1, and now you have substituted it in K2. Now please follow this arrow. Can you see? I will work for K1, I will utilize in K2. I will work for K2, I will utilize in K3. I will work for K3, I will use it in K4. So this is the beauty of RK4. It is interconnected, okay? And that is why it improves the results, okay? We will get better, for better accuracy. We will update the results at every consecutive step. Okay, so you can see k1 is used in k2, k2 is used in k3, where you can see for k3 I had x naught plus h by 2, and then k3 times k2 times h by 2. So k2 is minus 0.9277 and h by 2 is 0.25. All right, and you can easily substitute these two values. This is x, this is y, for this, for this f of xy. So you can easily substitute here these values. You can use a calculator, you can use MATLAB, you can use any software, and you can simplify it. Okay, so my values for k1, k2, k3, k4 are these. Now please pause the video and use your calculator and double check whether you get these values or not. If not, then watch it again and then simplify it, obtain k1, k2, k3, k4. Now use it in the formula number 1 by substituting I is equal to 0. Y1 is equal to y0 plus h by 6, and these k's. So what will happen, students? You will now substitute the data. We know y0 is 1. We know h is 0.5. We know k1 is minus 1.5. For your understanding, I have substituted the formula for k1 here. It is not necessary to substitute it here, but just to make it clear. Okay. Now the next step is more important. Now, by now, what have you attained? What have you achieved? You have got x0, y0, x1, y1, and we have already discussed that x values are already given. You just need to add 0.5 in the previous x value. So what is x2? X2 is x1 plus h. Okay, now you can see that x0 was given, y0 was given, you obtained y1. X1 is given, y is given, y1 is given, you will go for y2. So this is the procedure. X2 is given, Y2 is given, you will go for Y3. All right, so you can see here that you have got now the new K1, the difference between the previous K1 and this K1 is that now you have got the inputs X1 and Y1. Okay, so you can see here X1 is 0.5, y1 is the value that you have obtained using the RK4 method. So it is your achievement 0.4811. You will use it in the next iteration for K1. Now the new K1, this new K1 minus 0.6615, use it to find the new K2. How will you use it? You will say minus 0.6615 times h by 2. H by 2 is 0.25. Multiply it this value with 0.25 and substitute it here and so on. Okay, so in this way you will see that here why is it positive, because you have here k1 times h by 2 plus we have got here y1. You can see here this formula for k2. Let me clarify this point. Here put I is equal to 1. You get x1 plus h by 2, y1 plus k1 h by 2. Okay, k1 is given to you a negative value times 0.25, and then here y1 is given to you. What is y1? y1 is 0.4811, and after simplification you will get 0.3157. All right, so work on this problem and obtain all the values for k1, k2, k3, k4. Keep it in mind that you will update the x1 and y1 in the function, in the formula. You will substitute in this formula I is equal to 1, otherwise you will get the wrong answer. Okay, and you can see that I have already shared with you this table. Okay, you can see here that in this table I have organized all the data values. For example, you can see at x naught, y naught, you have got this k1, you have got this k2 for these inputs, f of 0.25 comma 0.625. So you can always verify your values. Similarly, I have obtained K2, I have obtained K3, and then K4. And with the help of these Ks, I have obtained Y1. With the help of X1, Y1, and then the new Ks, these new Ks, I can obtain Y2. All right, so you will refresh your input values, input data, and go for the next value. For example, if you want to obtain this value, for example, if this is y0, y1, y2, y3, if you want y3, what you need x2, y2, and then the new k values, this k1 minus 0.1435, this k2 0.1138. And how will you obtain it? You will substitute these values in the function. All right, so it will take some time to understand the method. Watch the video again with pauses, bring a notebook and a pen and write it on the notebook, and I believe that you will be able to build this table by yourself. Good luck. Thank you.